Hello everyone, my name is Youness. CHAWKI. I have a PhD in Computer Science, Image Processing and Computer Vision from Moulay Ismail University, Faculty of Science and Techniques of Rajlia, Morocco. The title of the paper is A Fully Automatic System for Assessing Similarity. Due to the explosion of multimedia quantities such as archive TV, various multimedia resources released on the internet. So, to provide an efficient and accurate functionality for users to access the desired information is an intense work in multimedia archival domain. So, the problem here, which presents a major challenge, is how to have quick access to these huge multimedia resources and also how to automatically access the similarity of the tags. Among the solutions of this problem is the live logging. Indeed, live logging refers to the activity of recording the digital data of all kinds related to the daily life of the individual. And the recorded data can be of the different types like images, text, sounds, quantitative measurement such as heart rate, sleep time. A variety of digital devices embedded with sensors should be applied to capture the data. Among all the devices, the digital camera is the most commonly live logging device used. The following figure shows a variety of live logging wearable devices. The main goal of this paper is to apply a new method to automatically assess the similarity using a real image dataset. So, in the feature selection, we're interested in extracting the features. Indeed, feature selection and dimensionality reduction is an essential phase in any image processing task. That's why we're going to focus on the important information. Like this information is local binary patterns, LBP, is a non-parametric but parametric method used to summarize local structures of images efficiently by comparing each pixel with its neighboring pixels. The following figure shows an example of basic LBP operator. The two-dimensional histogram in HSV color space. The color histogram is easy to compute, simple, and effective in characterizing the global and the local distribution of color in any image and separating the intensity of the color information chromaticity. The color histogram extraction algorithm uses 3 steps. The first one, partition of the color space into cells, association of each cell to a histogram bin, and counting the number of images pixels of each cell and storing their count in the corresponding histogram bin. The dynamic time warping DTW is an algorithm that allows to find the minimal distance between two sequences which can have different lengths. Indeed, let's consider 2 days to compare dA and dB. We use the local distance measured here between image E and G. The algorithm first starts by building a distance matrix C, representing all the pairwise distances between dA and dB. Then, the DTW algorithm is defined in the framework of dynamic programming to align the time series so that a total distance measured as minimized. So we have to minimize this. For the proposed contribution, we're interested in assessing the similarity of the days. So the objective of our model is to extract the relevant feature from images to efficiently assess the similarity. The development system is comprised of 3 stages. The first is pre-processing, second one distance computation, and the third one is the displaying results. For the first stage, it extracts the relevant features of images given in the input. First, we create 2 processes for each day, dA and dB. The first process converts images to HSV and then it computes there to demonstrate histograms and their slopes. The second process calculates the local binary patterns. For the distance computation, we compute the distance between these 2 images, E and G, using the dynamic time warping, DTW. For displaying results, after having the DTW matrix of all these images of dA and dB, we afterwards calculate the optimal pitch using the algorithm of backtracking from the point P end to the starting point P start. This figure summarizes the different stages of our proposed model. So we have the day A and the process 1, process 2, and the day 2, day B, dB, process 1, process 2, then distance computation between A and G, distance integration into DTW, optimal path, and displaying results. For the experimental results, we have applied our method to the real image dataset, egocentric dataset of the University of Barcelona, Europe. It is a dataset composite of 4,912 images carried by 4 persons using a wearable camera narrative. This figure shows an example of images on the EDUB dataset. The images in EDUB dataset are structured as follows. They are structured, the image is structured on 8 days, and for the first day, it's subject 1 refers to day n, subject 1 2 refers to day 2, and the same for all the 8 days. The following figure shows an example of the result of the query image. This is our query image, and all other images are the retrieval images. As we can see, all the retrieval images are similar to the query images. Same for this other example. This is our query image and retrieval images. As we can see, all the retrieval images are similar to the query images. The effectiveness of the proposed method measured by the Rocal precision curve. This is the Rocal precision curve. As we can see, all the curves of the used EDUB dataset are generally decreasing. all the score of the days are decreasing. That can be explained by the fact that we have chosen the best descriptor and nature of the images in the dataset are suitable. To evaluate effectiveness, sorry, to evaluate also the retrieval effectiveness, we use the accuracy as statistical comparison parameter for the proposed method. We use this formula where N is indoor images, out is indoor images, and this gives the number of the corresponding indoor, outdoor, and indoor images respectively. So, the following table shows the accuracies between days. From this table, we can conclude that the proposed method achieves satisfactory performance and provides an important accuracy between days. It achieves up to 25% of accuracy and automatically characterizing correspondence between days in an egocentric dataset. The table 2 shows the variance of the improved method. The low standard deviation means that most of the data are very close to the average. We could say that pre-processing and distance computation stage are better than those done in the other method. That means our method our approach is an improved method of the last this method. For the conclusion, an approach to automatically assess the similarity is presented. The obtained results show that our method is very efficient. This method helps to getting high accuracy in matching process. For the perspective, we will try to apply our approach to other datasets, and also we focus to use sophisticated feature extraction techniques like deep learning using Keras, TensorFlow, and other distance metrics. And thank you for your attention.